here we have some problems where we are applying the concept of differentials to solve some more real-world type applications. In this first one, we have a profit function. So this is an estimate of what the profit is going to be for a company based on the number of units it's producing. And it asks us to use differentials to approximate the change and the percent change in profit as the production changes from 105 to 110 units. So they're going to, or they're thinking about ramping up production. They're making 105 units. Let's say this is a car company. They're making 105 cars right now. They want to go up to 110, but they want to see how much more profit that's going to mean. And they have this profit function. So we can approximate that by using the differential. The change from 105 to 110 represents the dx. So if x starts out as 105, our change in x, or our dx here, we're going to call 5. And to find dy, which is the change in the profit function, or a good approximation of it, we have the derivative of the function times dx. Well, taking the derivative of this function isn't too difficult. Let's do that right now. So p prime equals, well, the 26,000 disappears. This becomes just 450. And then this would be minus 2x. So there is our derivative of the profit function. I'm going to put this in here and put in 5 for dx, and we should be able to calculate dy pretty simply there. So dy equals 450 minus 2x times 5, because that's our change in x. And x is 105. So let's put that in there. dy equals 450 minus 210 times 5, and when you crunch the numbers on that, I think you get 1,200. So there's our change in profit. That's the first part of the answer. They also wanted the percent of change in profit. So if they're increasing from 105 to 110 units, how much percentage does their profit rise? To figure a percentage, we're actually going to need to know the profit at this point at x equals 105. And to do that, we'll simply take 105 and plug it in for x in the profit function. So that's not too hard. So we're finding here p of 105, and that equals 26,000 plus 450 times 105 minus 105 squared. And if you crunch the numbers on that one, you should get 62,225. And then to get our percent of change, we'll take the change in the function over what it was originally. And you should get something around 0.019. Let's call it a 2% change in the profit. All right, let's try one more. In this one, we have a sphere. So maybe there's a company making spheres, and their spheres are supposed to be 11 inches. So maybe these are kickballs. They're supposed to be 11 inches, but there's a possible error of 1/16 of an inch. So that means it could be 1/16 of an inch less than 11, or 1/16 of an inch greater than 11. So a plus or minus 1/16. And we want to use differentials to approximate the possible error in calculating the volume of the sphere. Maybe we need to know that to provide proper packaging. We want to know how much volume it's possibly going to take up. Well, our change in x is going to be this unit of error. Our function is just the function for the volume of the sphere, and that is 4/3 pi times r cubed. And remember, for differentials, dy, that's going to actually be, for us, the change in the volume. You could call that dv if you wanted to. I'm just going to use the dy and dx notation. That equals the derivative of the function times dx, and x here is standing in for the radius. So let's take the derivative of this function. So v prime is, well, 3 times 4/3 would just be 4 pi r squared. And we can go ahead and plug this in now. dy equals 4 pi r squared times dx. And the dx is the change here in x, which is 1/16. And r squared, r is actually going to be 11, because that's what the radius is supposed to be. So let's go ahead and plug those numbers in. 4 pi times 11 squared times 1/16, and we can simplify a little bit here. 4 and 1/16 would just be 1 over 4. 11 squared is 121. So we should get 121 pi over 4. Now a couple of things here. This 1/16, that was a plus or a minus. So the volume is also going to be plus or minus. It could be this amount of volume greater than the standard amount, or this amount less than. And then since this is volume and our units are inches, this should be cubic inches. So this is how much the volume can vary if the radius is varying by up to a 1/16 of an inch. So that's a little bit of work with using differentials in some more real-life applications. My name is Larry. I'm a teacher at EdVisions Off Campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethisSchool.org. Thanks.